meter per second. This is between 200 millibar minus 850 millibar, 10 meter per second. This is probably the criteria. The wind shear is weak enough, the hurricane can start developing, right? And then let's look at what's the GFS data. So you won't surprise because the resolution is very different. This is 10 meter, this is a 10 kilometer, this is a 110 kilometer, right? So this has got to be much weaker. But you can see something very interesting. There's like a decrease of the shear and start increasing. And actually, the observed hurricane start developing starting from here, start doing intensification until almost like this point. This is the first time. This is like 6 hours. Okay? This is almost like the first time period of rapid intensification. Okay, and this is later on because at the beginning it's really the shear is too strong. It was unable to develop, and they're almost like 12 hours different when the shear reached the minimum. So now the question is really the shear is the problem or is the motion is the problem to make the hurricane fail to develop? And we believe, assuming now we believe this guy is really making it happen, right? Even I hope if I increase the resolution to the 3 kilometer, you'll get a stronger hurricane. So we are going to look a little bit more about what is happening. So this is still the delay. Okay, this is the one I want to show you the shear. So this is a control case, the NAM, and this is the 200 millibar minus 850 millibar. So you can see all the warm colors means strong shear. So this is Emily kind of attaching to the strong shear to the north. The beginning is north and then to the south. So the later on is still attached to the north. So let's look again. So it's kind of, the beginning is kind of south, there's a very strong shear going on, and then kind of detached a little bit, but then it's attached to the north part of the shear again. So you can see. And this very weak shear to the back of the hurricane. Unfortunately, here probably not the right position. Now we look at both of them. So this is you look at this one already, and you look at this guy. This is the one developed, right? So we'll see there's a very weak. There's a weak band, much wider and weaker of the shear coming out, and start doing it. And then you can see when this is attached to the strong shear here, this one doesn't. This one doesn't. Somehow there's an advection of the weak shear can help a little bit. Later it's attached to the shear again, but doesn't matter. Once hurricane form and it's really good in the shear, maybe the shear needs to be really strong in order to destroy it. But the beginning is probably very important. The genesis, the shear is really, really important. But after developed, the shear got to be a little bit even stronger to push it in order to destroy the hurricane, to stop the hurricane develop. Okay, so shear is one potential here. Now we try to do some sensitivity tests. Oh, sorry. So for this one, we just replace. All right, so this one we're just, like the main difference here, right? I want to say this one first. So for this, the first try, we just replace AV moisture increment, put it into the NAM, see what happens. So the NAM becomes very heavy. Now it develops. Okay, we replace the moisture only. Everything's the same. How about the next one? How about we just try to do only half? We just get rid of all this moisture in the MRI and just leave this guy here. What happened? It developed. It's even stronger. Okay, so the moisture here seems to matter. And now how about the other side? We do on the other side, and what happened? The hurricane developed not that strong. So in the end, it's really the right side, the column, the half, it's really the matter. So why that one is matter? We also looked at the total precipitable water again, and I think this is the one, the winner in the end is not that strong, right? But I still don't know how to prove this is probably not really the big deal because the number is really big. So I think the other one is really shear is the question. So why the shear become weaker? That's the question. What makes the shear weaker? When we look at the cloud here. So you can see the beginning, there's no like a very weak cloud here, but there's a strong, deeper cloud here. And we believe this guy is the one making the difference. Why? The big deep cloud can transport the momentum and reduce the shear, the vertical shear. And we look at the observation. There's a small cloud here. Believe it or not, it's like just a cloud. And maybe that cloud does something to the hurricane Emily. So this is the animation from the GOES data. You can take a look. It's coming out later. This is only 1 day. Okay, the whole thing is 1 day. The interval is 1 hour. You can see this guy's coming out. The end of the animation is when the storm start developing. So you can see that cloud quickly developed. A few hours later, dissipated, and hurricane start developing. That's observation. Okay, and that's how also happened in our simulation. But our simulation delayed because everything just the beginning the shear was too strong, and it needs a little bit time for cloud to develop. So you can see this guy come out here, and then dissipate it, and then this is the time, this is category 1, okay? So I just leave everything here. So it really just tell you, it's very interesting, that cloud seems to make something. I'm not telling you that cloud can make a hurricane develop, it's just like to prevent not develop, okay? That's a model's problem, it's not a reality, okay? Thank you.
Yeah, let's just have one question because I think we only have about 10 minutes for coffee break.
If you look at what causes the large, strong vertical shear in the model compared with the data observation, so the difference is large.
In the model, why is it a strong shear? Why do you think that?
It's more than double, like the observation should be 8 meters per second, but the model.
But
15.
you know that observation is really from the GFS. First, the GFS is causal observation. The second, GFS is not a God. There's nobody say the GFS is right, correct. But somehow the GFS data still have a trend. You have a decreasing of the shear and then increasing of the shear. The same trend as a model. But it's much weaker. First, it's because of the resolution. Okay. The second, it's maybe just underestimating something.
So the horizontal resolution supposedly doesn't change the vertical shear, right?
No, the horizontal shear. The horizontal.
Environmental shear.
Yeah, that's environmental shear. That's environmental shear.
That was going to be my question. I don't understand that argument. So I don't think resolution should have an impact on the environmental vertical shear.
Okay.
Well, let's thank all of our speakers, and we have a coffee break now. I don't know if there's any